Okay, we're looking at work questions for Unit 1.4. What is the probability of rolling a 3 or a 4 using a standard die? Now, they're mutually exclusive events, so the probability of a 3 on a standard die is 1 over 6, and a probability of rolling a 4 is 1 over 6, so the probability of R3 or R4 is equal to 2 over 6, and that is equal to 1 over 3. So the answer is C in that case. Moving on, Kara's shirt collection is shown below. Her shirts are jumbled in a drawer. Determine the probability that Kara randomly draws each of the following: a pink shirt or a purple shirt, a pink shirt or a short-sleeved shirt. Okay, so you can't both be purple and pink. So let's say A, probability of pink is going to be 2 out of, she's only going to take 1, is equal to 2 out of 5. And the probability of purple is 1 out of 5. So the probability of pink or purple is equal to 3 over 5. Okay? Because it's mutually exclusive. You cannot be a pink shirt and a purple shirt. Okay? But can you be a pink shirt and a short sleeve shirt? Yes, you can. So the probability of pink, we already know, is equal to 2 over 5. And the probability that you're short sleeved, probability that short, is 3 over 5. Now, if we were to add them, then it'd be P pink or short. If we were to add them, it'd be 2 plus 2 over 5 plus 3 over 5, which is 100%. And we know that I could pick up that's not 100%. That's neither short or pink. So what do we got to do? We got to subtract the probability that it's pink and short. And that's equal to, a pink or short is 1 out of 3. Oh, pink and short is 1 out of 5. The probability I pick a pink short sleeve shirt is 1 out of 5. So we have to subtract 1 out of 5 over here, right? So probability of A or B is equal to the probability of A plus the probability of B subtracted the probability of A and B when they're non-mutually exclusive, when there is an intersection of short sleeves of pink, right? So that's the explanation. Next, this work problem. What is the probability of rolling a sum that is not a 7 or 11 with a pair of dice? So what is the probability of rolling a sum that is not a 7 or an 11 with a pair of dice? So I'm going to read this as not a 7 or is an 11. I'm not going to say neither. Otherwise, it would say neither 7 nor 11. So make sure it's not ambiguous, okay? So neither 7 nor 11 would be not 7 or 11, but the probability of it being not a 7 and an 11. So let's take a look at that. The probability it's not a 7. Well, first of all, is it mutually exclusive? Okay, well, the probability that something's a 7, rolling a 7, gonna get that right there. Let's do that again. The probability of rolling 7 is equal to, we already did it on our thing. It was basically, we could count it, right? You could count 1 and 6, 6 and 1. We could count 2 and 5, 5 and 2. We could also count 3 and 4 and 3, in which case we'd get, and that's basically it, 6 out of 36, right? That's a probability of getting a 7. The probability of not a 7, the complement, is equal to 1 minus 36 over, 1 minus 6 over 36, which is equal to 36 over 36. Where'd I get that from? That's from that 1. Take away 6 over 36, which is equal to 30 over 36. So P that it's not a 7 is 30 over 36. What's the probability that it's 11? Well, there's only one way to get an 11, and that's with a 6 and 5, or actually two ways, and 5 and 6. So probability of rolling an 11 is equal to 2 over 36. Okay, so what's the probability of rolling not a 7 or rolling an 11? Well, first of all, are they mutually exclusive? And the answer is, well, let's take a look at that. Not 7. Well, not 7 is basically 7's out there, and we have 2, 3, rolling 4, 5, 6, 8, 9, 10, and actually 11 is actually in there. So what we have to do is we say it's not mutually exclusive. It shares the case of 11. So it's P of R, not 7. Oops, get that here. Erase that. P of not R7. Oops, let's make that the same color. Plus P that we roll an 11 minus P, the probability I roll not 7. Oops, keep making mistakes. Okay. Not 7 and R11. Okay, so what's the probability that it's not 7 and 11? Well, the truth is, as you saw in the Venn diagram, I'll draw it a little bit more clearer here, is that when I draw this, right, basically only 7's on the outside, and we had 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 in here. And when it rolls 11, that's fully in there, right? So we're just going to subtract it anyway. So the probability of R7 and R11 is just simply the same thing. So it's actually the probability of not 7. We'll see how that works in a second. So the probability of R7 is 30, not 7, rolling a 7 is 30 over 36, plus 2 over 36 subtracted by 2 over 36, right? There's two instances in there that are not 7, so it ends up being 30 over 36, which is the same thing as the probability of not being 7. See, one is an event in the other, so it's not mutually exclusive. Refer to the Euclid deck of cards in number 2. Let's just skip that and do number 7. Oh, that also refers to the Euclid deck in card number 2. So I guess now it becomes clear that we probably should look up what is a Euclid deck. Euclid deck. Whoops. Euclid deck. There. A standard Euclid deck consists of 24 playing cards consisting of A, King, Queen, J, 10, and 9, each of the 4 suits. Forget the Joker. Let's just do with Ace, King, Queen, J, 10, and 9. Okay. So let's do question 6. Okay, determine the probability. So we have it. Let's just write it down so that we're not we don't forget, has an ace, king, queen, jack, 10, and 9, and for each of them, there's 4 of each, so that's 24 total. Okay, determine the probability of randomly drawing either an ace or a spade. So each of these have a heart, diamond, club, or a spade, right? So there's going to be 6 spades, 6 clovers, clubs, 6 diamonds, and 6 hearts. So what is the probability of randomly drawing an ace or a spade? So the probability of an ace is basically 4 out of 24. And the probability of a spade is probably 6, not probably, it's 6 out of 24, right? Because there's 6 spades, right? So there's 1, 2, 3, 4, 5, 6. And then the probability of an ace and spade is 1 out of 24. So the probability, and it's not mutually exclusive, right? So the probability of ace or spade is going to be 4 plus 6 minus 1 all over 24, right? And if we want to just do basic math, we can just do the probabilities added, like 4 over 24, we got that from here, plus 6 over 24, minus 1 over 24, which is equal to 9 over 24. What is the probability of randomly drawing a red card? Well, the red card is basically hearts and diamonds. So B, probability of red, is equal to 12 over 24. And the probability, or diamond, well, what's a diamond? Oops. A diamond is, basically there's 6 diamonds, so, oh, for God's sakes, P diamond equals 6 over 24. Now, all diamonds are red, so probability of diamond and red is basically 6, it's basically, has to be both, it's basically 6 over 24. So if we do the math, probability of red or diamond is equal to, one or the other, is going to be equal to 12 over 24 plus 6 over 24 minus 6 over 24, which is the same thing as it just being red. And we saw this before, it's like 50%. 50%. Now, if we drew this in a Venn diagram, think about it. If this was all red cards, half of it would be diamonds, and half of it would be hearts. There's no diamonds out here, none. So essentially, the probability of it being red or diamond is the same probability as it being, oops, what did I do? Oh, red or diamond, because or is inclusive. The probability of it being red or diamond is, the same probability as it being red. Because if it's red, it is a diamond. So half of them are not. Half of them are spades and that, right? Okay, next question. So we have the Euclid deck again. Oh, ace, king, queen, jack, 10, and 9. What is the probability of drawing a 9 or a 10 or a diamond from the deck? Okay, well, what's the probability of rolling a 9? Right, you have heart, diamond, spade, club. Right? So you have 4 over there. So the probability of a 9 is equal to 4 over 24, right? We have 24 total. The probability of a 10 is equal to 4 over 24. So if you think about it, these are non-mutually exclusive. Sorry, these are mutually exclusive events. So the probability of a 9 or 10 is actually equal to 8 over 24. Okay, or a diamond. Now, if it's a diamond, it includes this. Now, these are non-mutually exclusive. We got 1, 2, 3, the J, but this is counted twice, right? If we count it there. So what's the probability? We'll take this as one event on its own. Probability of a 9 or 10 or diamond is equal to the probability of 9 or 10 plus the probability of a diamond, subtract the probability that it's both 9 or 10, oops, and a diamond. Oops, let's fix that up a little bit. 9 or 10 and diamond. There's actually a good notation for and. We're not using it yet, so we'll use it later. And that's basically, what's the probability of 9 or 10? We already did that. It's 8 over 24. Plus the probability that it's a diamond, 1, 2, it's basically 6 over 24. 1/4 of them are diamond. Subtract the probability it's 9 or 10, right here, and a diamond, that's basically 2 over 24. So that's equal to 8 plus 6, basically 12 over 24, which is equal to, 8 plus 6 is 14, minus 2 is 12, which is equal to half, 50%. Okay, how did I solve this problem? Basically, I made the non-mutually exclusive event one event, and I said it intersected right there with the diamond. Okay, Marie is playing a board game and can win if she rolls a sum of either 6 or 8 or doubles with a standard pair of dice. What are the odds against Marie winning in a given throw? So first of all, let's calculate the probability. Actually, let's not do it like that. Marie is playing a board game. Well, let's figure out all the probabilities, okay? Rolls either a sum of 6. What's the probability of rolling a 6? Well, that's equal to, well, if you do the math and you calculate it, we know there's 36 and 6 over ns, which is equal to 36, 5 over 36 if you count it. And the probability of rolling an 8 is equal to, well, 2 and 6, 6 and 2. What else can you be? It can be 3 and 5, 5 and 3. And of course, it can be 4 and 4, right? So that's for 6. Oops. That's for 8. So the probability of that and 8, oops, EIGHT over N of S equals 5 over 36. Now, what's the probability of double? The probability of doubles is equal to, well, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, and 6. 1, 2, 3, 4, 5, 6. So it's equal to 6 over 36. So very much. What are the odds against? Okay, forget about odds against. What's a probability of winning? What's a probability of winning? Well, that's equal to the probability of 6 or 8 or double. Okay, so do we have any mutually exclusive, well, or inclusive? Let's think about that for a second. We already have all the ways it can be 6. We have 1 and 5, 1, 5, 5, 1. We have 4, 2, 2, 4. And of course we have 3, 3. And then we have the ways it can be doubles. Oh, by the way, there's some inclusion in here. See that 3, 3? We have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And then, of course, we have 8. We have the ways it can occur to be 8. That's 2, 6, 6, 2. We have 3, 5, 5, 3. We have 4 and 4. Oh, it's already counted. So we didn't even count it twice. So as you can see, we have a little bit of an overlap. But 6 and 8 are mutually exclusive. So if we count it, P, 6 plus P, 8, right, plus P double, then we have to subtract, because P double is not mutually exclusive, subtract probability of, whoops, we have to subtract everything that's, well, anything that's non-mutually exclusive. So we could say probability 8 or double 8, subtract the probability that it's double 6. And what's the probability of 6? We already got that, 5 over 36. What's the probability that it's 8? Well, that's 5 over 36. What's the probability that it's double? Well, that was 6 over 36. And of course, there's 1 out of 36 chance that it's a double and an 8. And there's 1 out of 36 chance that it's a double and a 6, which is essentially 2 out of 36. So how do we do this? 16, that's 16 right there. Take away 2. It's equal to 14 over 36. And that is the probability of winning. But that's not what it asks. It asks what are the odds against Mary winning. Now, if you remember the odds questions, let's erase some of this stuff right here that we don't need necessarily. If you remember the odds questions, P, the odds against is equal to P of something not happening to the odds of it happening. So I already know that that's going to be, what's the probability of not winning? Prime is equal to 36 over 36, 1. Take away 14 out of 36. We end up getting 22. 22 out of 36. So the probability of not winning is 22 over 36 to the probability of winning, which is 14 over 36, which is equal to 22 to 14, which is 11 to 7. Okay. And finally, This is something that I'll leave for you to do on your own, and let's leave it.